Just a quick intro. My name is Dmitriy Setrakyan. I'm one of the founders of GridGain. I'm also Chief Product Officer there right now, and I'm also on PMC of Apache Ignite, open source project. How many of you have heard about Apache Ignite here? All right, a few hands. Okay. How about Apache overall? All right, so today we'll be talking about Apache Ignite project and how it actually integrates with Hadoop and Spark, and how we can actually complement each other and make each other better. And at the end, we'll actually do a quick demo on showing Apache Ignite capabilities and Spark capabilities on top of Apache Zeppelin. Apache Zeppelin is a visual tool, allows you to visualize and run interactive analytics on various projects, including Spark and Spark and Ignite. So quickly, what Ignite in-memory data fabric is. Again, it's an in-memory data fabric. So what is a fabric? A fabric is a collection of in-memory components. All of those components are independent from each other, and all of those components serve the same goal. They, in one way or another, they will improve performance and scalability of your application. So some of these components include DataGrid, which is essentially distributed cache, if you will, with additional features. But it's essentially spreading out the data across the cluster and caching it in memory and providing fast access over that data, transacting on that data, querying that data using SQL queries. There is also compute grid for computing on that data, streaming grid, service grid, and Hadoop and Spark integration. So all these components are provided within Ignite in-memory data fabric. Generally, our users will start off using one or two. You never have to use all of them. Data grid probably being one of the most popular components. But as the use case progresses, I usually see that people will pick up compute grid almost right away, and then other components as needed. So the main advantage of this platform comes not just from having all these features, but from using them together. Just think about, I mean, if you distribute data across the cluster, the least desirable thing is to start moving the data around. So it's very important that all these components are aware of each other's data locality. All of them are aware where the data is stored, and all of them interact with the data locally on the servers, on the nodes where that data is stored. So if you think about compute grid, the way it integrates with data grid is by sending computation exactly to the node where the data is. Same goes for streaming. Data is streamed exactly to the node where it will eventually cached and is processed there as well. Same goes for service grid. Services are collocated with the data that they're working with. And same goes for both Hadoop and Spark integration. We have pretty cool integration, which I'll be talking mostly about today. And just a few facts about the platform, about the fabric. First of all, it's an Apache Ignite project. GridGain is a company that provides enterprise features on top of Apache Ignite. But Apache Ignite project itself is part of Apache Software Foundation. You can go there and download it for free. Very easy to install, comes as a zip file. You just unzip it. You start up multiple shell scripts, ignite.sh, and all of them will automatically start discovering each other, forming a cluster. So very easy to get started with it. The project comes with a bunch of examples included into the downloadable, huge amount of documentation, and very friendly community. So if you have any questions, you can ask directly on the user list or on the dev list, and you'll get help pretty much immediately. So installation is fast. Getting started is relatively fast for a distributed cluster project. And there are no hardware requirements. You can use any type of commodity hardware. So we don't, we're a software. We're not a hardware. We're written on Java. So anywhere that you have a JVM, you can run Apache Ignite. We'll gladly consume all the resources you make available to us. the more memory you give us, of course, the more caching we will do, the faster things will get. My favorite jigsaw puzzle of Apache Ignite, probably one of my first contributions to the project was the jigsaw puzzle. So just a list of all the components that are available within Apache Ignite. Not exhaustive list, but probably at least the main ones. So DataGrid is the backbone of the data storage, of data distribution within Apache Ignite. Most other components are integrated with the DataGrid or based on top of DataGrid. So compute, service, streaming are all integrated with DataGrid in a way that they will always collocate computations and streaming and services within nodes where the data is stored. Hadoop acceleration actually has several components built into it, and or Hadoop and Spark, actually, I should say. One of the main ones, I don't know if you're familiar with the in-memory file systems that operate with Hadoop. A project used to be called Tachyon, and now I can never remember its new name. But essentially, it's a distributed file system. We also provide a distributed file system within Ignite. Our file system is implemented on top of DataGrid, and getting pretty good feedback. It does provide very nice plug-and-play acceleration for HDFS-based or HFS-based, if you will, applications. So it plugs in natively into Hadoop deployments. We also have our own implementation of in-memory MapReduce. So Hadoop actually has several pluggability hooks, if you will. One of them is file system, another is MapReduce. So we plug it into MapReduce as well. So in that combination, if you use our MapReduce and our file system, you'll get pretty nice acceleration out of the box without changing any code. So you just plug our project into it, and your same Hadoop code will run on top of our MapReduce, on top of our file system, but a lot faster. So since everything is based on top of DataGrid. By the way, if you guys have any questions, raise your hand as I go. This is very compact, 30 minutes. Raise your hands as I go, and I'll stop and answer the questions. So let's not wait all the way to the end. So let's talk a little bit about DataGrid, since everything is based on top of it, and then we'll switch into Spark and Hadoop integration. So as I mentioned, DataGrid essentially is a mechanism to distribute data in memory within your cluster. You can think about it as a distributed hash map, if you will. A bunch of nodes in the cluster, every node has its own portion of data. There's a concept of data ownership. So every node owns a set of data collectively across all the nodes. You have your complete full data set. It's very different from sharding in a way that we're not doing range-based or kind of predefined splits. We automatically evenly distribute keys ourselves. And one of the main features that DataGrid provides is multiple ways to talk to the data. The main way is just like the first way you probably would see is JCache. It's a JSR 107 standard, which essentially provides a concurrent mapish API with many concurrent operations, ability to collocate primitives and methods to collocate with data, etc. But a very nice and neat API to use to get started and to interact with the data grid. However, just one way. Another way, and I would say the main differentiator of Apache Ignite, is our SQL capabilities. So all the data that is stored in memory, regardless of how you store it, or whichever way you store it, can be queried using standard ANSI 99 SQL. We support all the whole 9 yards of SQL. You can do group bys, joins, you can do averages, sums, aggregations. The cool thing about joins is you can do distributed joins. Essentially, imagine you're storing person table or organization table. You need to query all persons together with organization. A very easy and natural way to do it would be a join, SQL join. Without that capability, you would have to implement that query manually. Very painful process. You query all the persons, you query all, or maybe all the organizations, and then all the persons that belong to that organization join it together in code. So very painful and slow process. In Ignite, that happens in a simple SQL statement. We support joins in both collocated and non-collocated fashions. So if your keys you're joining on, and many people will probably understand partitions for joins are collocated, then joins are very fast, no data movement. Every node will collocate based on the data stored locally on that node, and join based on that data and return the results. So those type of joins work very fast, but it's not always possible to collocate. In my experience, about 80% of data you can take care of and collocate it properly, make sure everything works nice on the same collocated fashion on the same server. About 20% of the data will have to go across the servers, no matter what you do. And to support those use cases, we'll also support non-collocated joins. Took us a while to add that feature. We recently released Ignite 1.7. The community actually released Ignite 1.7, and I welcome you to download and give it a shot. It actually has this, one of the main features is this non-collocated join functionality. And lastly, the last way I would mention to talk to your data is using compute features. So you can send a closure to the data, you can send a fork join task or a MapReduce task to your data, and then that way just talk to your data in parallel across multiple nodes. So all those ways are natively supported within Ignite. It doesn't matter to us which way you use to talk to the data. We also provide JDBC and ODBC drivers to talk to the data, so you can interact with Ignite as with a standard distributed database, except that this database is a scale-based, not eventually consistent, it's always consistent, it's transactional. We have many usages of Ignite come from Wall Street. When it comes to money, you cannot afford data to get inconsistent for a little while and then get consistent again. So we're kind of always consistent, we're fully transactional. No matter where the failure occurs, the data will stay intact. So all these features are supported within DataGrid. I'm not going to focus on distribution, I don't think I have enough time, but generally speaking, data can either be replicated or partitioned within the cluster. How many of you from Yahoo here? All right, so you guys know what data distribution and data partitioning is, or otherwise we wouldn't be able to use your search engine. So I'm going to skip forward and talk a little bit about Apache Ignite for Spark and Hadoop, and then we'll switch to maybe some questions and a demo. So first and foremost, when you integrate with Spark and Hadoop, very important to integrate with Yarn and Mesos. So we do integrate with those, so you can use those resource managers when you're working with Apache Ignite. Will natively, so all those policies will natively apply to Apache Ignite. So how do we integrate with Spark, and how do we integrate with Hadoop? So let's start with Spark. In Spark actually is a very nice platform. It's a processing platform. It's not a storage platform, right? If you think about Ignite, and when I was talking about DataGrid, we store data, we cache data in memory, we keep it in a consistent fashion. Spark, every time you compute, it loads data from some storage, computes on it, and then discards it. So if you want to share state between Spark applications or Spark jobs, you would have to load it, process it, then spit it out to some other storage and have another job or another Spark application pick it up and read it. So that's a kind of clumsy interaction between jobs. It's not always needed to interact, but when you do need to interact, you're pretty much limited to using disk or HDFS or maybe Cassandra or any other database like storage to interact or pass state between different Spark applications. And given that we do data storing very well, for us it was very easy to provide an RDD based on RDD implementation in Ignite based on native Spark RDD API. So essentially the class is called IgniteRDD, and it allows to it essentially allows you to store data within to store data within native RDD in Spark, but at the same time talk that RDD will become a cache within Ignite. So Ignite cache, since it's partitioned, can natively be partitioned within Spark RDD API. So when that happens, you essentially come to this architecture that you get one shared memory layer for Spark applications. You essentially use IgniteRDD with some additional methods that we have added for such integration. For example, think about it. If you need to share the state, now you need to be able to update data within RDD, and you need other applications or job to read and receive events and read that data. So in that case, IgniteRDD has to be mutable. So we did add some mutable functionality to IgniteRDD, so to allow you to process data in parallel and update RDDs in parallel. Whenever RDD is updated, essentially Ignite cache gets updated. And it can be deployed actually, Ignite cache can be deployed together with Spark workers, Spark jobs, or as a standalone Ignite cluster. We've seen all types of deployment. It's a very popular feature, by the way. If you look on our user list, there's a lot of usage there. And it's not just to share state. Since since RDDs are based on top of data grid, you get a pretty cool benefit. If you remember, I mentioned that we support SQL very well. Our use case is not just to do analytics. Our use case is also to make sure that we can process thousands upon thousands queries per second. So we have a lot of transactional use cases. On top of a lot of use cases, we have many OLTP use cases. And when it comes to OLTP use cases, you cannot afford for a query to take 5 seconds or 10 seconds. You have to, if you're processing hundreds of thousands of queries per second, your queries have to take milliseconds. In order to accomplish that, you need indexing. And so indexing is natively built into our data grid. And because IgniteRDD is implemented on top of data grid, indexing comes there for free. You can run SQL over IgniteRDD. The SQL will be indexed, and it will execute a lot faster than a Spark. Spark doesn't do indexing simply because it doesn't store data, so it can't really index something it doesn't store. So Spark, to do a query, like a join in Spark over 5 GB of data, it will also do full scan, always do full scan. So no matter how you twist and turn your SQL query in Spark, it will eventually end up doing a full scan to find something that you're looking for. In Ignite, it's a lookup into a B tree or a snap tree, whichever index you're using inside of Ignite. So faster SQL is one of the reasons people come in to use this type of integration. So instead of query taking 10-15 seconds, you have a query that takes 10-15 milliseconds. Instead of sitting there and watching this query, watching that will spin, you get a result back instantaneously. So that's one of the major benefits of this type of integration. Another type of integration, if you remember, I mentioned that we have a distributed file system. So you can also use our Ignite distributed file system, IGFS, to share data within Spark jobs. In this case, there's no SQL because it's a file system. The data is unstructured. But you get this type of pluggability if you have some integration between Spark jobs and HDFS. You can, without changing code, you can now plug in IGFS and get your state shared across the cluster. But now it will be shared in memory. Yes, there's a question?
So this in-memory file system, does it have security based on user identity, or does it carry over the same Hadoop level?
It will carry over whatever you have on Hadoop. So it natively, it's a file system, it's a HFS, implements HFS API. So whatever you, it plugs in natively into Hadoop. Whatever you have configured in Hadoop will natively transparently shift into our file system. All right. So, and another thing here to note is that we can also write through to HDFS. So if you still have your HDFS, you want to store some of the data, you actually get to pick and choose what you want to store in HDFS. We'll automatically write it through to HDFS, or if data is not in file system, we'll automatically load it on demand from HDFS. So pretty cool integration. How do you know, how do you get to choose? Is it an RDD you want to use or a file system you want to use? Well, I mean, most of the time my answer would be, if you're working with objects, then you should be working with RDDs. If you're working with files, maybe you have log files, text files, PNG files, then maybe a file system is a better medium to store files. So it depends on your use case. RDDs are more suitable maybe for API kind of use, and file system is more suitable for storing files. In either case, you will get a pretty cool, pretty nice performance boost. For example, I'll just give you an example out of the project we recently. We didn't do the project, but we recently helped one of our users implement that project. And if you know, there is a Splunk project called Hunk. And essentially what that project does, it allows you to search over HDFS and search and look for analyze log files and look for stuff in those log files. So, and that search capability is built on top of HDFS and on top of native Hadoop MapReduce. So by simply plugging in Ignite without searching, so it's a third-party product. We don't even have access to their code and none of that. We simply configured Hadoop differently. We configured Hadoop with our HDFS, with our file system, and we configured Hadoop with our MapReduce. Out of the box, after that configuration, the users got about 2 to 3x acceleration, simply by plugging in our MapReduce and plugging in our file system. So it's pretty cool functionality, very neat feature to try. Briefly on this, before I hand it over to my colleague, essentially everything in gray here is what Hadoop does to execute a MapReduce job, and the blue line is what we do. So there's no, our scheduling is very aggressive, and a lot of processing happens directly with the data that is cached in memory within files, so we don't have any serialization or deserialization. We don't have a name node. In DataGrid, we'll always know which key belongs to which node, which file block belongs to which node, based on a hashing function. We don't need to access a name node to find the location of the key, so we don't have that overhead either. So this type of execution is very fast and allows us to produce this type of execution. And now I'll hand it over to Valentin. He'll show a quick demo. How many of you, by the way, know what Apache Zeppelin is? All right, one hand, two. Okay. So you'll like this tool. It provides nice visualization, and we'll run queries in Spark and in Hadoop. No, in Spark and in Ignite, and you guys will see quickly the difference in performance between same SQL running in one system and versus another. Both are in memory systems. Okay, I'm going to unplug.
So while they're getting set up, question?
Yeah.
Sure.
For the execution part of the SQL queries, as well as the RDDs which are there, for the use for the common application, is there a specific time for which they are in the cache, like round robin or first in, first out?
Okay, the question is, I'm sorry I don't have a microphone anymore, so I'll
You
screen.
can use one of the hands.
So the
Switch it.
So the question was, how do you move active hard data into cache and remove cold data from cache? So we have eviction policies. Everything in Ignite is pluggable. We have several eviction policies that come out of the box, and you can plug in your own if none of ours works. LRU is there, FIFO is there, and some others I don't remember on top of my head. But essentially, yeah, they will be automatically evicted if you don't remove them yourself. Make sense?
So for the performance tuning, all the parts would be placed as per those eviction policies. right?
All the what? I'm sorry?
For the performance tuning, as per whatever policy it is, accordingly the RDDs and the queries execution paths would be maintained?
Yes. So you would definitely consider this. So RDD will work only over what is in memory. So if whatever is evicted, obviously will not be queried. So you need to tune the eviction policy to make sure that whatever you query is in memory. A lot of times our users will just be able to load the data in and just query, and as the new data is loaded or maybe passes through, the old data gets automatically removed. So a lot of times there's no manual intervention here, it just happens behind the scenes.
Thank you.
Right? Any more questions? Right.
Can you hear me? All right, so my name is Valentin, and I'm lead architect at GridGain company, and I'm also the committer and PMC of one of the PMC members of Apache Ignite. I will show you the very quick demo of how you can execute this SQL queries on top of Spark and Ignite and compare performance. So I created a simple schema, which basically consists of two classes, which are then used to create SQL tables and run the queries. So the first one is organization. It's just very simple, just has the ID, which is kind of a primary key, and the name. Both fields are indexed, will be indexed in Ignite. And the person, which is kind of an employee, which also has an ID as a primary key, which has a name, which has an organization ID, so it belongs to one of the organizations, and it also can have the manager ID. I will also use it in one of the queries. So basically, if it has the manager ID, then it basically references his manager. If the manager ID is null, he's the manager himself. And so the person also have the salary. All right, so this is the schema. I will run the queries in the Apache Zeppelin project.
Can you make the
Yes.
bigger, the font?
More.
Yeah.
Nice. All right. So I have basically all the data prepared and preloaded, both in Spark and Ignite. So I have a Spark worker running on my laptop, and I also created two data frames based on JSON files. And I created two tables based on these data frames. And I have a couple of queries that I will run first with Spark. So the first query is basically very simple. It just selects the name of the organization and the average salary of the persons in this organization. So we have to basically join the person and organization tables. We have to calculate average, and we will also select by some organization ID. So we will show the result for 3 organizations here. All right, and we will order the results as well. Okay, so let me run the query. So as was mentioned, in Spark we don't have indexing, so Spark has to scan the whole data set, and it takes a while. My data set is very small, so it takes around 10 seconds. With a larger data set, it will take much longer because it will still have to scan the whole data set. The second query, a bit more complicated. It will basically join the person table with itself and query employees of a particular organization, and will also show the manager of each employee in this organization. So we join person with person itself and also with organization, and then select by organization name. Right, let's run this one. This actually takes even longer, mostly because of 2 joins instead of 1 join. takes a while. All right, we're done. So we took 17 seconds on our small data set. Now let's do the exact same queries with the Apache Ignite. So we created this special interpreter for Zeppelin. So we basically just specify the interpreter like this, and then provide any kind of the query you want. So this is absolutely the same query, average salary, and selecting by organization IDs. And if I now run it with Apache Ignite, it will actually be very fast. So it comes back with the results instantaneously. I can even change something here. For example, change the ordering, and it will still be very fast, and results are changed. And the second query, remember it took 17 seconds with Spark. Let's run it with Ignite, and it's also very fast, even faster than the first one. So it took 0 seconds. Basically, it's a sub-second latency of the query execution. All right. So basically that's it. The demo is available on the GitHub, so you can download it. You can check out, and run it by yourself. If you have any questions, you can ask them.
Any questions from the back? Let me give you the mic. So are the data frames used in your demo example cached?
I'm sorry?
So in the Spark demo, you have created data frames.
Yes.
So are these data frames cached? Are you strictly caching those data frames?
No, basically I just created the data frames based on the JSON files I have.
Right. So Spark also provides a explicit action called cache, where you can cache these data frames in memory, so that then it will be apple-to-apple comparison, Spark SQL and Ignite.
This data is cached in memory, actually, in Spark. So it's loaded in Spark, it's cached in memory. So it's still full scan in memory, or in this data will take a while.
So we created the data frames there, and we did not call cache method on the data frame. Unless we call cache method, these data frames are not cached.
So the data is, the way Spark loads the data, for one-time processing, the data is loaded in memory, right? So we create a table, we define it, it's loaded. So on top of that, there's some additional caching that needs to take place.
That's right, yeah.
And the data would still be full scan, right?
So yeah, we can take this offline. So
yeah, exactly. Yeah, we can take it offline right after this. You can show us.
Sure.
One more question here.
How does this compare to InfiniSpan, other caching providers, distributed caching?
You mean in terms of performance? InfiniSpan, does InfiniSpan have SQL queries?
No.
It doesn't have SQL queries.
You don't know, yeah, cache.
So it's hard to compare.
It's also cached, that's why.
But what do you want? What's the question?
In terms of the performance, in terms of whether it's cached using some other caching provider. For example, Oracle has its coherence cache.
Alright, so yeah, there are many caching providers. There are several ways you can compare to caching providers. One is performance. So I would say that we constantly publish benchmarks against other open source projects. and independently from Apache Ignite, we're on our own. And we internally run benchmarks against the non-open source projects. We just cannot publish them because the projects are not open source. And the performance, I would say, we're very comfortable benchmarking against the caching solutions. And there's also feature set. I mean, a lot of those projects are just caches, so you interact with them just using one API. It's either JCache API or something similar, something called the sort. You interact with Java. In Ignite, it's Java, it's API, a Java-based API, then JDBC, ODBC, SQL, compute, and also analytic type of integration. So a lot more flexibility on data interactions.
So how is the feature comparison with, let's say, Coherence or let's say SAP has also HANA, yeah.
So those are absolutely two different beasts. On performance, I would say we're very comfortable against either one. From a feature standpoint, from a JCache API, Coherence, for example, also supports JCache. So from that minimal API, you get the same feature set. However, if you start moving into transactions or into SQL, that's where you'll get the main benefit of Ignite. There's no SQL in Coherence, ironically, because it's an Oracle-based product that doesn't have SQL. But there's no SQL there, so just imagine doing a join without a SQL. If you start querying data without SQL, a lot of that has to be done manually and painfully through API, which is and in multiple trips, which is not very convenient. And from transactional standpoint, we're built to use transactions, and for example, Coherence would be always recommended not to use transactions because of performance. So we'll be probably 2-3x faster on transactional performance. SAP HANA, for example, is a different beast. First of all, it requires its own hardware to deploy, then it only deploys on 2-3 maybe servers. It requires you to load the whole data set in memory in order to achieve performance. So it's a much more different scaling characteristic, much smaller scale. Ignite, for example, can scale to thousands of nodes. SAP HANA will scale maybe to a few, maybe 1 or 2. Generally, it's deployed on 1 or maybe a couple. So every product here is different. You have to look at what's important to you and what criteria you're looking for.
So you're saying SAP HANA will not, SAP HANA will not be able to scale as much as Ignite?
Yes. So essentially, first of all, it requires its own hardware. You have to have your hardware certified by SAP in order to run SAP HANA. So you can't just take a Linux blade and run it. And second of all, generally, to achieve good performance in SAP HANA, they'll recommend that you load the whole data set in memory. In Ignite, you load the whole data set across hundreds of servers. So you can take much smaller servers, load it, spread it out like butter across all the servers, and start querying, and we'll index locally on every server separately. So if you run a query, it will, let's say you have to query a terabyte, and you have 10 servers, each server holds 100 gigabytes of data, then a terabyte of data will take 10 seconds, let's say, for query. But if you split it across 10 pieces and do it in parallel, then each server will take 1 second to query 100 gigabytes of data, and that becomes 10x acceleration in many cases.
Okay, thank you everybody. Thank you.